In this video, we're going to apply the sine and cosine rules to an arbitrary triangle. The first example we look at is to find the angle at C, and we have a triangle where we're given 8 meters, 10 meters, and we're given the angle 36 degrees and the unknown C. So just let's take a look at that. We'll take a look at this one first, and I'll just do a rough sketch of the triangle we're looking at. Very rough sketch. This we were given is 36. Mine is completely not to scale. 10 and 8, these are meters. So the angle at C is what we're looking for. So we have 2 lengths and 1 angle. So if we're looking for the angle at C, we can use the sine rule. So sine C over the length opposite 10 equals sine 36 over its opposite, which is 8 meters. So I can look at sine C equals 10 over 8 sine 36, and indeed to find C we get the inverse of all of that. So sine minus 1, open brackets, 10 over 8 sine 36 degrees. So that should give us the correct answer. Let's look at the calculator now for a moment. Now notice I've got radians on the calculator. I do need to switch that to degrees so we're consistent with the question. So 3, oops, what have we got there? Delete. Just make sure I've got the right shift mode and 3. Okay, so around degrees. So what we want is sine inverse, and I'm going to in there put 10 sine 36, close brackets, and then over 8, and close the final bracket, and we should get a measure in degrees of 47.28. So C equals 47.3, just rounding that degrees. Okay, so that's the first example. Let's take a look now at another example. The second example, we're looking at finding all the angles A, B, and C. We're given a triangle of length 15 meters, 17 meters, and 19 meters. So we'll take a look at this example, and again, I'll do a very rough sketch. The rough sketch is just showing here we've got 15, here we've 17, and this one is 19. Whoops. So 15, 17, 19, and we're asked for angle at A, at B, and at C. Okay, so let's use the cosine rule here, because when we have no angles and just lengths, we need to use the cosine rule. So we know that the length 19 squared, this is to find A, 19 squared equals 15 squared plus 17 squared minus 2 times 15 times 17 cosine A. Cosine A. So I can rearrange this. Cosine A equals 15 squared plus 17 squared minus 19 squared, all divided by 2 times 15 times 17. And in fact, to find A, the angle at A is going to be cosine inverse all of the above there. So what we'll do is we'll just pull up the calculator and do that on the calculator. So just clear down the last one. We're in degrees, so we're looking to do shift cosine inverse. And inside that we're going to have a fraction, and on the top is 15 squared plus 17 squared minus 19 squared all over 2 times 15 times 17. And that should give me an angle at A of 70, we'll just call it 72.5. So A equals 72.5. So mark that up there, 72.5. Now we need to find B and C. Well, we can use the sine rule. So I guess if we want to look for B next, sine rule, angle at B. So we're going to say sine B over the length opposite, which is 15. Sine B over 15 equals sine of 72.5 over the length opposite is 19. So sine B is 15 sine 72.5 over 19, and B is sine inverse of that. Sine inverse of that. I'll do that on the calculator. So we're looking for sine inverse. Just cancel out that. Shift sine inverse. 15 sine 72.8 all over 19. And that equals, I need to close the bracket maybe, and equals 48.95, so we'll call that 49 degrees. Which leaves me with just one angle. Now we know all the angles in a triangle always add up to 180 degrees, so C must be 180 minus the sum of A and B, 72.5 plus 49 degrees equals, calculator very quickly, so we clear that, we have 180 minus 72.5 plus 49, and that gives me angle at C equals 58.5. So 58.5 degrees. Okay, so we found all three angles, A 72.5, B 49, and C 58.5. So we'll take a look at the last example. And the final example is to find the angle at P and the shortest distance from Q to the length PR. And we're actually given the lengths 13, 15, and 18, all in meters. So I'm going to take a look at this one. Just clear this down, and I'll sketch the triangle. Again, a rough sketch. So maybe we should do it like this, would be a bit better. And here to here. So we are given P is this angle, Q is here, and R is here. We have 13 meters, 15 meters, and we have 18 meters. So the first angle we're looking for is the angle at P. Now again, we need to use the cosine rule to find this angle. So we'll just say cosine theta equals, so it's the surrounding angles, so we've 13 squared plus 18 squared minus 15 squared, all divided by 2 times 13 times 18. Now if we want to find theta, we'll get the cosine inverse. So we've cosine minus 1 of the above. Just put that in there. And I'll take up the calculator to do this. So we have cosine inverse, shift cosine, and on the top we have 13 squared plus 18 squared minus 15 squared over 2 times 13, so 2 times 13 times 18. And just close the brackets. So we get the angle. Oh, that's very strange. 13 squared plus 18 squared. I've done cosine, not cosine inverse. I see the problem. So I clear that down and correct. Apologies for that. So I have to clear that, and we're going shift writing pad is failing. Okay, shift cosine inverse. And now we have 13 squared plus 18 squared minus 15 squared, all divided by 2 times 13 times 18, and equals. So that's much better, 55 degrees. So we'll just round it to theta equals 55 degrees. Now I'm calling it theta, but it's actually the angle at P. That's what we're looking for, the angle at P. Now the second part of this was to find the shortest distance from the point Q to the length PR. I'll just call this point S. So when we're looking at the shortest distance, it is the distance that will form a right angle triangle with, will form a right angle with the length PR. So I'll just mark in this is 55, and we'll take a look now at the shortest distance. So the length from, we're looking at the length QS. So the length QS is what we're looking for. So QS over sine 55, which is the angle opposite, must equals the length 13 over sine 90, the right angle degree. Now sine 90 is in fact 1. So QS, the shortest distance between point Q and the length PR, is 13 sine 55. As I said, sine 90 is 1. So let's have a quick look on the calculator and do that. So we have 13 times sine 55 degrees. And that gives me 10.64. So it's 10.6 meters. 10.6 meters. And that's our final answer. So that's it for this video. Thanks for watching.